Hey kids, welcome to day 2 of partial fractions. So we talked about how partial fractions can kind of cause us to cry a little bit when somebody asked me to decompose a whole fraction into its parts, especially when it's an algebraic fraction. But when we have non-repeating linear factors, that's the most ideal situation. It's a little bit of a sniffler if I have some repeating linear factors. But notice what's true here. Oh, dagger. When I factor this denominator, what do I get? I get an irreducible quadratic factor. That really makes me cry. So here's what we got to do. Again, we take a moment to cry, but then we say, all right, I got to get up and I got to move. So the first factor x is just linear, so I can put an a above it. But the second factor in the common denominator is an irreducible quadratic, so remember I need to put a linear expression up there. Boo-hoo. So what am I going to do here? Well, I'm going to do the same thing that I did before, where I'm going to multiply through by my common denominator. So what happens here? Let's see. Let me clean this up a little bit and get rid of the parentheses. Now remember, believe in the equal sign. What's on the left does equal what's on the right. So notice on the left, you have a coefficient of 5 in front of x squared, a coefficient of 7 on x to the first, and a constant of -4. So let's go over here and group our x squareds. Group our linears and group our terms that have nothing with them. Factor an x squared out of this. And now use equality. The coefficient of x squared on the left is 5. To be equal, the coefficient in front of x squared must be 5. So what does that say? The coefficient in front of x to the first must be 7. On the left, what does that say about what's on the right? The coefficient of x to the first must be 7. The constant on the left is -4, so the constant on the right must be equal to -4. Hello, A and B. A and C. A is equal to -1. C is equal to 7. So can you solve for B? that wasn't nearly as bad. Look, I spent all that time wailing and sobbing, and it actually wasn't that bad. So what's my final answer? -1 over x plus 6x plus 7 over x squared plus 4. What if you don't believe me? You can check your work, right, by taking these two fractions and simplifying it. And you will take those two parts, the sum of those two parts, combine them together into one fraction, and if you've done your math right, you will get 5x squared plus 7x minus 4 on top of x cubed plus 4x. That wasn't so bad. Oh, what's this? It's repeated irreducible quadratic factors. Okay, this really does make me cry. All right, I'm over it. I'm stopped crying. What do I have to do here? X squared plus 1 has to be represented one time, and then has to be represented twice. Okay, so those are my two partial fractions, but what do my numerators look like? What do your numerators have to be when you have irreducible quadratic factors in the denominator? Sniff. I got a linear thing there, and I got another linear thing here. Oh, my Lanta. What am I gonna do? All right, start the same way. Multiply through by the common denominator. Right, one of the x squared, right, your common denominator is x squared plus 1 squared. One of them will cancel out with this one, and both of them will cancel out with the cx plus d. Now we just have to do some algebra. The algebra is a little more annoying than the previous problem. Believe in the equal sign. The coefficient of x cubed on the left is 2. You only have one x cubed thing on the right. Guess what its coefficient is? So therefore, 2 must be equal to a. How about your x squared term? The coefficient is -1 in front of x squared. How many x squared things do you have over here? Only one. So what must b be equal to? Now let's go look at c. The coefficient of the linear term on the left side is 5. How many linear things do you have over here? X factored out of a plus c, right? So that means that a plus c must be equal to what? What is the coefficient? Here's your coefficient. Those are just numbers. Has to be 5. What do I do now? Let's see. I took care of that. I dealt with that. I dealt with that. I dealt with that. Who's left? No x's. No x's. Oh, so b and d have to be my constant, right? Well, what's my constant on the left? Ah, right? My constant over here, there's actually a plus 0, right? So how does that help? Well, I know what b is, don't I? So 0 is equal to -1 plus d. So what is d equal to? Now what? Well, how about here? A. 5 is equal to 2 plus c. So what is c equal to? Don't I have everybody now? So what is my answer? My final answer is my partial fraction decomposition is 2x minus 1 plus 3x minus 1 woohoo! Longer, but not too bad. Even with that repeat, how can you check your work? Right? Multiply it back out or simplify. All right, one more. Go back and look at your notes. What was step 1? We haven't had to do it. Oh, dagger. Really dagger. The degree of the denominator is not bigger than the degree of the numerator, so I have to divide first. Oh, that long division keeps coming up to, right? Keeps coming up. Factoring, slant asymptotes, right? Just to divide. Now I got to divide in order to do partial fraction decomposition. So the first thing I have to do is represent this as a sum of a whole plus a fraction. So what do I multiply x squared by to get 2x squared? Right, degree 1 is less than, so I'm done. So step 1, you've already broken this up part of the way, right? There's nothing more you can do with 2, but you have to further split this one apart. So x squared minus 4 is non-repeating linear factors, thank goodness. So I can just put a and b up here. And now I'm going to kind of ignore this 2 for a little bit. I'm just going to carry that 2 on down. But I can call Arnold back to the situation with these linear factors. Arnold is highly useful. What do you want to let x be? Oh, I forgot I got to multiply through by everything, right? So technically you have 2 times x squared minus 4 plus a times x plus 2 plus b times x minus 2. You're going to let x equal 2. So that's going to terminate this one. And that's going to terminate this one. And over here, you just have 2x squared plus x minus 14. And when you put 2 in, right, you're going to get 2 times 4, which is 8, plus 2, which is 10. 10 minus 14 is negative 4. 2 plus 2 is 4. Then what are you going to let Arnold do? So I'm going to get the same thing. Negative 2 squared is 4 times 2 is 8. 8 minus 2 is 6. 6 minus 14 is negative 8. Who gets terminated this time? This factor still gets terminated. Now this factor gets terminated, but this one stays. Negative 2 minus 2 is negative 4. Good. So now go back up here. Two plus a was negative 1, so you could write minus. And whoa. Now, I could have made this a little easier on myself and just dealt with the cloud. As long as I didn't forget this 2, I could have just focused on here and said to myself, oh, I could have just done x minus 2 and x plus 2 is equal to x minus 6 over x squared minus 2. Right? And that's okay as long as you remember, don't forget this, that you still have this 2 up here from the original problem, right? So at that point, I would have gotten x minus 6 is equal to a times x plus 2 plus b times x minus 2. And then I would have still brought Arnold into the situation and let x equals 2, which would have killed this one, and I would have got negative 4. Right? And I still would have got a is equal to negative 1. And then I would have done x is equal to negative 2 here, and I would have gotten negative 8. See where I'm going here? Is equal to would have killed what? Negative 2 goes, would have been here. Okay, would have done the same thing. The only danger in doing this is in your final answer forgetting this original 2 from your division. So just be careful with that. Okay. All right, that's it. Have fun with these problems. They do get a little bit hairy, that's for sure. Again, the most common ones are your non-repeating linear factors and your repeating linear factors. They don't all have these nasty, your irreducible quadratics, especially when you have multiple of them, add to my work, and so does having to do division first. All right, so just watch out for those. Otherwise, the other ones get to be fairly routine with practice, of course. All right, I will see you later.